Hello class, Craig here one more time. Well, we are in week 8, Portfolio Project Week. And I thought I would explain something that I've kind of glossed over before, but we're going to be using it in week 8. It's called the P-value. I also want to dispel some misunderstandings that several of you have had. First of all, the P-value. What isn't it? P-value is not related to proportion. Now I know why many of you would think that, because we used the letter P to stand for proportion in our week 7 and our week 8 work. We also used the Greek symbol pi for proportion, but we also used the letter P. No, P-value and proportion, no relation to each other. So what is the p-value? Well, as you will see, the p-value is an alternative method of analyzing a hypothesis test. Now, what we've done in week 7, and which I'm going to review real quickly right now, is to calculate a t-statistic or a z-statistic and compare that to a t or z critical. Well, using the p-value is just an alternative to that. It's probably even a little bit easier than that, but since our book stressed calculating the t-stat and the z-stat, I stuck with that method. And well, as you know, you've learned a lot in this class, and there's a lot of confusing topics, so I didn't think we needed another one. Okay, but we are going to use the p-value this week, and so we need to briefly know what it is. Hey, it's pretty simple. Don't worry about it. Okay, now let's see. What else do we know about the p-value? Well, here's the textbook definition. It's the level of significance. And again, when you think about level of significance, well, there, we called that our level of significance, right? It's the rejection zone. It was either alpha or alpha over 2. Yeah, there was our level of significance right there. Well, the p-value is going to be the same thing. Gee, we're going to call this the p-value. Of course, we're going to, getting sloppy here, we're going to create this this zone in a different method, but that's all it is. That's level of significance. P-value is the level of significance where our calculated t-statistic or z-statistic, I'll just use t, is equal to t critical. All right, probably kind of weird to wrap your head around that one right now, but let's just move forward and I think you'll see what I mean. Okay. Oh yeah. How do we interpret these p-values? Again, I said it's pretty simple. Evaluating p-values. Here it is. This is the whole thing. If the p-value, and where are we going to get a p-value? Well, the computer's going to generate it for us if we use Excel's data analysis, which we are. You can also calculate it. There's a function that'll give you the p-value, and it's not rocket science. We haven't done it yet, but it's available. It can be done. Okay, if the p-value is less than the significance level of the test, and again, our significance level, that's going to be 0.05 or 0.01. If the p-value is less than that significance value, ooh, here's the tricky part. Well, no, it's not tricky. We reject the null hypothesis. That's all there is to it. Well, it wasn't much different before, right? We simply compared our t-critical to our t-statistic, and if our t-statistic was less than, if it was greater than our t-critical, we rejected the null hypothesis. So it's just an alternative way of evaluating our hypothesis test. Okay, let's back up though now. Let's back up to week 7 and revisit how we evaluated hypothesis tests in week 7. Well, as many of you know, let's kind of do an example here. Let's say we had a hypothesis test where the true value of the population mean was equal to 5. And we'll contrast that with an alternative hypothesis where the true value of the population mean was not equal to 5. Now, right away, some of you are picking this up, but not everybody. Do we have a one or a two-tailed hypothesis test? Well, we get that information right here. This is a two-tailed test, and how do I know that? Well, since the alternative says that the population mean can be greater than 5 or less than 5, it means it can be on either side of the true value, which that simply defines a two-tailed test. So what do we do in these regions? Well, you know what we do. We reject H0 out here, and of course, we also reject H0 out here. And we fail to reject if we're in the middle. So let's see, what is this value? Well, first of all, some more information. Let's say, in this example, that the population standard deviation was unknown. What does that tell us? Well, if it is known, you probably remember that we can use a z-test. But since it's unknown, we're going to be doing a t-test. Okay, let's define our significance level. And let's say that our significance level alpha is equal to 0.05. Now, after that, I'm going to have to find a t-critical. I'm going to have to go to the back of our book, and with my degrees of freedom, how many degrees of freedom do we have? Don't know. Well, let's snuggle that in right up here. Let's say n's equal to 50. So degrees of freedom are n minus 1 or 49. T-critical, let's see, where do we get T-critical? Back of the book. And let's see, we're going to take some parameters back there to find T. We're going to take, is it alpha 0.05 or alpha over 2? Well, since we have a two-tailed test, half of our significance level probability goes to each tail. And so we're going to take alpha over 2 since it's a two-tailed test. And we'll take our degrees of freedom. And let's see, what is that? That's 0.025 and 49. And let's see, let's go to the book. Textbook tells me that our T-critical is 2.010. Okay. Now, where does T-critical fall? Well, T-critical falls right there. Yeah, that's how we define T-critical. So what are we going to compare T-critical to? Well, we're going to compare that to our calculated T-stat. And our calculated T-stat is equal to our sample mean minus our hypothesized population mean divided by our sample standard deviation divided by the square root of n. And let's just say, for this example, that our T-stat ended up right here. Yeah, oh boy, I'm running out of room. I hate this. Yeah, move over. All right, there's our T-stat. And of course, now we have to make an interpretation. We've got the information we need. And what do? We say, well, okay, our calculated t-stat is not greater than the t-critical value, which means we're in the region in the center. We failed to reject the null hypothesis. Well, that's what we did in week 7. Now there's an alternative to do this using a p-value. And let's look at that. Let's see how much of this stuff do I actually have to trash. Probably most of it, so let's just get rid of it. Okay. With the p-value concept, we have something like this. We have our calculated test statistic. I didn't write calculated on the last page, but I'll write it here. Calculated test statistic. And for us, it was a t-value. Yes, that's right. Okay. And now, this value is no longer 0.025. If we draw this line where our calculated test statistic is, then this area is equal to the p-value. Aha. Okay, so let's see. This point is also something else. By definition, we said that's equal to t critical. And by definition, the area after t critical is our area of rejection, and it's our p-value. So what's going to happen is the computer's going to give us a p-value. And once again, we simply have to interpret it. Let's do a couple simple examples. Okay, so in our first example, the p-value the computer gives us is 0.013, and let's just say for this test, our significance level was equal to 0.025. Now recall, what we needed to check was we needed to compare our p-value to our significance level. And we said if p-value is less than significance level, then we reject H0. So let's see, is our p-value less than our significance level? Well, let's see, 0.01, 0.0. Yes, it is. In this case, we would reject H0. That's not too tough. Let's change it around. What if our significance level was quite a bit higher? Oh, I'm sorry, our p-value, 0.18. And in this test, let's say, not 0.005. How about 0.05? That sounds like a one-tailed test, doesn't it? Or perhaps a two-tailed test at the alpha equals 0.1 level. Let's see, p-value, is it less than our significance level, 0.18? No, it's not. In this case, we're going to fail to reject H0. It's that simple, folks. Computer gives you a p-value. There's your test right there. And there's your answer right there. Your interpretation right there. All right, well, let's see. I do have another video, and it's a rather long one that's going to walk you through how we're going to generate the data for our Week 8 portfolio project. It's really not too bad. In fact, I think it's probably the actual computer work is simpler than we've had in many other weeks. The interpretation, that's going to get a little bit tricky, but I leave it up to you to read your text, to ask me questions. You might have some about interpreting those residuals, but maybe not. I'll leave it at that. All right, folks. This is Craig signing out. Have fun. Good luck. We're almost done. Yippee.